So we're going to start transforming our trigonometric functions. Remember a, h, and k from previous chapters? That's what we're talking about. However, for the AB level, we're not going to mess around with h, or our horizontal transformations, and we're not going to mess around with k, our vertical transformations. We're just going to worry about a and b. It's likely that you actually played with these values in ICP, or again, if you have taken or choose to take physics in the future, those are most likely the ones you're going to mess with. And there's a reason for that. A, our A value, actually controls vertical stretch, or possibly compression if you have something like a half or a third, which is the amplitude, or how high or low that wave goes. So if you ever wind up playing around with waves in a future class, A is one of the variables you're likely to mess around with to change that amplitude. Remember, for our parent functions, the amplitude was just 1, because the A value was just 1. But for all others, that amplitude is going to be whatever the A value is. If it's 6, the amplitude is 6. If it's 10,401,000, that's your amplitude. So again, A is that number in front, that multiplier. On the inside, when you're multiplying the variable x by some constant, we didn't play around with that very much when we were graphing absolute values or quadratics, but with periodic functions, that horizontal stretch or compression is important because it affects the period. Now, unfortunately, it's not quite as simple as just, hey, A is the amplitude. With B, we need to do a little bit of work. The period is actually 360. That comes from our parent function. And we are going to divide that 360 by B. So if B is a 2, the period will be 360 divided by 2, which is 180. So B does take a little bit more work. Let's go ahead and try a couple of examples, starting with a cosine here. So the easiest thing to note is just that number in front. That's our amplitude. And amplitude will always just be that number in front. The reason we care about amplitude is because from our midline, from that 0, this function will go as high as 2 and as low as -2. So that's going to be the min and the max for this function. Getting the period takes a little bit more work. B is 3, so the period is going to be 360 divided by 3, which is 120. So what that's telling us is that between 0 and 120 degrees, this cosine graph is going to make a complete cycle. Now remember, cosine starts high. So cosine is going to start at its max, then go to the midline, then go low, back to the midline, back to max. If you don't remember those patterns, you could always use your calculator to help you, except notice I was able to do this without even knowing the x values yet. If you learn the pattern, you can actually get the graph going before even knowing your x values. Now eventually we need to figure out those x values, but we don't need to know them right away. So in order to figure out those x values, remember there are 5 critical points. We're always starting with the x value 0. And we're going to end at the end of the period. So 2 of these are given to us. 0 is where we're going to start. The end of the period is what we calculated above. Then we have to do some work to find the other 2. The other 3. So in order to do this, it's important to recognize the symmetry in the graph, the left-right symmetry there. So in order to find the middle value, it's the middle between 0 and 120. So a couple of ways you could think about that. Probably the easiest is just to divide 120 in half and get the 60. So at 60 degrees, this cosine reaches a minimum. In order to get this value, what we'd call that first quarter, you can either divide the 60 in half, or you can divide 120 by 4, because we're taking a quarter of the whole period. Those will both give you the same value, which is 30. And then the easiest way to find this last value Well, if the first one is 30, and then the next one gets us to 60, which is 30 plus 30, we can reason that that pattern will still hold for the next quarter. So we're going to have 30 plus 30 plus 30, which is 90. And those give us our 5 x values, 0, 30, 60, 90, 120. So there we have our transformed cosine function. Let's do a sine example. So now we're taking a look at a sine example. Note that our amplitude is 3. You can tell that right away just by looking at that first number. So the amplitude being 3 is enough to tell me what should go on my vertical axis. 3 will be the maximum, and -3 will be the minimum. The period is going to be 360 divided by 4. So my period is just going to be 90, because 360 divided by 4 is 90. So I'm going to have to make a complete cycle of sine between 0 and 90 degrees. Remember, the benefit to learning those patterns is that I can actually make the graph without any help from the calculator at all. Sine starts in the middle, then goes high, back to the middle, down to low, and then ends where it starts. So taking the time to learn that pattern can help you out there. No calculator work required. Getting these points in the middle is a bit trickier because now when I cut 90 in half, that part's not too bad. 90 cut in half is 45. But when I go to cut that half in half or cut 90 in fourths, I will wind up with a bit uglier of a number. 90 divided by 4, or you could do 45 divided by 2, is 22.5 degrees. So it is possible to have these important values, these critical points, happen at decimal numbers. That's okay. 22.5 is a totally valid angle. You would have messed around with angles much uglier than that in geometry. 22.5 is just fine. And then again, remembering that's our first quarter, 22.5. Our second quarter gets us up to 45. And then our last quarter, well, that just means I'm taking 3 of those 22.5s, which will be 67.5. So a bit trickier than the first example, at least getting those 5 angles, but definitely manageable, something that you can do. Let's throw some fractions in there. At first glance, when people see the fractions, they kind of quiver a little bit like, oh no, 1/2, what do I do? Keep in mind the amplitude, its definition and what it is, doesn't change just because a fraction's shown up. That amplitude is now 1/2, which means the highest that this function is going to go is 1/2. The lowest it will go is -1/2. Now that fraction for the period is certainly interesting. Remember, period is 360 divided by b. But now my b is a fraction, 360 divided by 1/3. Well, this is a KFC problem. We keep the first number, we flip the fraction, and change the sign. Dividing by a fraction is the same thing as multiplying by the reciprocal. So what we really want is 360 times 3. 360 times 3, that is 1,080. It's possible that you already kind of had an idea of what that looked like from skateboarding or snowboarding. A 1080 is when you go around 3 times. Well, this is our circle, and we've gone around that circle 3 times. So the 1080 there checks out. So between 0 and 1080, this function makes one complete cycle. The function in question here is sine. So again, without any calculator needed here, sine starts in the middle, goes high, back to the middle, goes low, and then finishes where it started. So getting those x values, so far I've started with the middle and worked outward from there. Some of you might recognize that, hey, I could just cut this thing by 4 right from the very beginning, and that's true. That is one way you can save a little bit of time. 1080 divided by 4 is 270. And then you can actually go from there. That first quarter is 270. So the second quarter is going to be 2 of those 270s, which is 540. And then finally, that last quarter will be 3 of those 270s, which is 810. And that's another way to go about this. What's nice about trig and nice about symmetry in general is there's usually more than one way to do something. So this does wind up being a bit faster if you're looking for a quicker approach. Granted, this relies on a bit of fraction sense. Just for fun, note that if you did 4 of those 270s, that would get you right back to 1080. So there is a nice double check built in if you want to go this route. Last but not least, we'll take a look at a cosine example with some fractions. The amplitude isn't a fraction in this case, so that's great. Our amplitude is 6, so that's going to be the maximum that this function reaches. The minimum then will be -6. But now we have a pretty ugly b value. So remember, to find the period, we want 360 divided by b. So we're going to divide by 3/4. Well, we keep the 360, we flip the 3/4, and we change the sign. So that will wind up being the same as 360 times 4/3. Now your calculator can help you out there, or you can try a bit of mental math. 360 divided by 3 is 120, and 120 times 4 is 480. Again, if you're not as comfortable with the fraction arithmetic, feel free to go ahead and use your calculator. This is why we hand them to you. They are helpful for that fraction math. So between 0 and 480, this was a cosine graph, so it will complete a complete cycle from the high down to the mid, all the way to the low, back to mid, and finishing at high. As far as when that happens, what angles get us those critical values, I'm going to go ahead and stick with the quarters method because it is a bit faster. So I want 480, cutting that in fourths, which gives me 120. 2 of those 120s gets me to 240, and 3 of those 120s will get me to 360. Keep in mind, you can also double check at the end by doing 4 of those 120s, which will get you right back to 480. So this method works a little bit faster than the previous method, but keep in mind you're welcome to do it either way. You could cut the 480 in half to get the 240, and that has its own built-in check as well. So you're welcome to pick your method. You're welcome to use a calculator to help you out with these. Remember, you will get the calculator on the test and the final, so feel free to use whatever method works best for you. At this point, we're done graphing our transformations. This is the last new thing of the section. So study hard, let me know when you're ready for a test, and if there's anything else you need, trigonometry, identity formula sheets, a calculator, chargers, just let me know. I'll see you soon.